My name is Giovanna Bermano, and I'm the Director of the Center for Obesity Research within the School of Pharmacy and Life Sciences at Robert Gordon University. And here with me is Teodora Stoyanova.
Yes, I'm a final stage PhD student working with Giovanna.
So we thought to give a bit of a background about the Center for Obesity Research, and as the name gives away, we are interested in obesity, and the ultimate goal of core of the center is actually to decrease the incidence of obesity-related diseases in overweight and obese individuals. So we are all familiar about the issues associated and the health consequences of obesity. But being obese, it decreases kind of the length of the life expectancy of the people. But maybe what is not known as much is that being obese, there is a higher risk of developing a lot of comorbidities like cardiovascular disease, diabetes. And actually, recently, it's becoming evident that obesity could be considered the cause, it's suggested as the cause of liver failure in a lot of obese individuals, and also increase in cancer. So within the center, we are interested in identifying the molecular determinants of obesity-associated diseases. In particular, we are interested in cancer, colorectal cancer, cardiovascular disease, and non-alcoholic fatty liver disease. So what we do is we use in vitro and in vivo models of obesity, of any of the diseases. And if we have access to clinical samples, we use them as well. And with molecular biology techniques, we kind of trying to dissect the mechanisms which are linking the obesity to the disease. And also, we are very much interested in looking at the interaction between different tissues within the body. So with obesity, we have adipose tissue, which is increasing sizes, and it is very active in sending out molecules to our tissues, which then will affect the metabolism and the physiology of the different tissues. So by focusing on this, in identifying the mechanisms, we are hoping to be able to then design preventative strategies or target therapeutics for the management and prevention of comorbidities. We tend to do this in focusing on particular molecules, or because of my background in nutrition, I would say nutrients. So nutrients, and especially micronutrients, are very important for the cells to function correctly. And so we wanted to know how modulating the nutritional status of a cell or of the individuals or the model we are working, we can affect the different pathways we have identified. In particular, I'm interested in the micronutrient selenium, which is really important for maintaining the redox status of a cell. So following on from this, I'm interested in identifying novel nutraceuticals. We are working in collaboration with different partners, but within the university, with the Center for the Center of Natural Product in Health. And we have such a close collaboration that we are looking at different natural products as a potential source of nutraceuticals. And that's where the project that Teodora has been involved for the last three and a bit years comes into it. Obesity is actually classified from WHO as an excessive amount of fat in the body. to create damage or disease. So this is actually the definition. However, obesity is an accumulation of lipids in different parts of the body. The main part is the adipose tissues, and we have different parts in the body where we can accumulate, where the adipose tissue is normally present. So it's under the skin or actually inside in the abdomen part. And the two different types of adipose tissues are actually different. And maybe until 25 years ago, adipose tissue was just considered one tissue which didn't have any function in the body. It was storing lipids, but protecting us from the cold and protecting us if we fall, kind of to absorb the fall. As I said, 20-25 years ago, it's becoming more evident that actually it's a very active tissue that produces a lot of molecules, and the majority of them are inflammatory molecules, which are then secreted and they go into the system, into the body, and then they can create damage. But so that's kind of the idea of obesity and how it creates problems and damage health. When someone is very obese, then the lipids, the extra fat can deposit within the different organs. And like in the liver, we have this kind of a new disease called fatty liver disease, which is an extra accumulation of lipids in the fat, and then damages, and is not, the tissue, the liver is not working as it should. Similarly, in the extreme cases, you can have fat around the heart, and that prevents the heart to pump the blood and compress and pump the blood against. Maybe a clinical level, the manifestation of obesity are very high cholesterol in the blood, possibly high blood pressure and hypertension. So those are kind of the main symptoms. And then diabetes is very closely related.
So as Giovanna touched upon, obesity is a global crisis, but I'll give you a bit of figures to kind of show you the magnitude of it. According to the World Health Organization, 13% of adults over 18 years old are living with obesity, and 39% are overweight. So if you compare these numbers to Scotland, actually here, 28% of individuals over 16 were found to be obese, and 65% were found to be overweight. So the data for Scotland captured a slightly younger population compared to that of the World Health Organization, but that is still 2/3 of Scottish population that is overweight or obese. And I think these are some staggering numbers. So there's really a big importance on therapies for the treatment and the prevention of obesity. Therapeutics are currently on the market. They're associated with a wide array of side effects, and some of them can only be prescribed for short periods of time rather than as a through the life treatment. And also they have very variable efficacy. So this is where this project comes in and is looking for novel bioactive compounds from seaweeds for the prevention and treatment of obesity. We chose seaweeds as a starting natural product because they have been used as a food source for thousands of years, and whole seaweeds as well as various extracts from them have been shown to have a lipid reducing effect both in vitro, in vivo, and in clinical studies. So for the project, we were mainly focused on looking at energy metabolism and how it has changed by the treatment. However, we also look at oxidative stress and inflammation, which are both increased during obesity and are very tightly linked to the condition.
Seaweeds in general do have a high content of selenium. So selenium is normally found in the soil, so in the ground or in the seabed. So depending on where the vegetables or the seaweed grow, they can take up and they can be rich or less abundant in selenium. So yes, so we don't know. We actually haven't measured exactly in the seaweed that Teodora is working with if the amount of selenium, but is probably a mixture of different micronutrients, trace elements, and also polyphenols.
Collaboration has been really important for this project because the expertise that we have here at cell and molecular biology and how they are influenced by different treatments. However, the company that we work with, Algaia, they are kind of masters of seaweed. So I had a placement in their R&D facility in France, 2 placements actually, where I produced my seaweed extract, and they have been really a fantastic source of information and knowledge for the composition, the way of extraction, and how different parts of the seaweed can be used for different things. So it has been really enriching working with them, with someone that is from a completely different sphere than the one I'm working with and that we are familiar with. So the next steps from this project would be we have identified an extract that is showing quite good activity on energy metabolism and oxidative stress and inflammation, and it would be quite nice to look at mechanistic studies to determine the specific mode of action by which we are seeing these results. And also have to write up my thesis.
So that's the very short term.
Yes.
The last one is the very short term view of the future for Teodora. As a group, we are really interested in continuing this type of work. And during Teodora's project, she has developed a couple of model a cellular level, but also using C. elegans model, so a whole organism to be able to study in details some of the mechanism, the mode of action she found into the cell, a single cell, and translate this to a whole organism. So the idea is to continue this type of work and using different sources of extract, not just the seaweed, but as a group and in collaboration with Professor Cherry Wainwright, we are interested in using in the valorization of different byproducts from the agriculture or the food and drink industry. So we have quite a few projects ongoing where we look at the valorization of this type of byproduct with the idea of creating new nutraceuticals or just find bioactives which can add value to the whole circular economy and industry and sustainability as well.